Hey, there we go. All right. Hi, I'm Byron. I work at Facebook. And at Facebook, relatively recently, we published this thing called GraphQL, which is our data query language for our client applications. And today we're going to get into this a little bit more, explore some of GraphQL, some of its core principles, why it's powerful. But first, I think maybe is a little bit more interesting is the story of where GraphQL came from. Their story starts more than 4 years ago, in 2011, when Facebook was just starting to get serious about mobile. In 2011, Facebook revolved around the web. The web is really a big part of Facebook's DNA. It's something that we deeply understand, we have a lot of skill in, and Facebook was, and in many ways still is, architected to support the web. So this is a high-level overview of what Facebook's architecture looked like at that time in 2011. We have a web server responsible for receiving requests from a browser, fetching data from databases, various services, generating UIs in the form of HTML, and then quickly delivering those back for rendering via browser. Pretty standard. And we had some iOS and Android teams at this time, but those teams were really small. The apps could only do a small portion of what you could do on the website, and they were really falling behind. They were falling rapidly behind as Facebook for Desktop expanded its capabilities. So if we were going to be serious about mobile, we needed a way to catch up to the Facebook Desktop, and we needed to choose a mobile architecture that would allow us to reuse as much of Facebook's existing code as possible. So we built native apps that were simply mobile web browsers wrapped in a native frame and visited a slightly customized version of our mobile website. And this allowed us to reuse all the work that was going into our web server, and it didn't change how engineers at Facebook were used to thinking about building stuff. And for the primary goal of supporting Facebook on mobile, this was awesome. This was a huge success. We were able to develop a considerable surface area of Facebook for mobile devices in well under a year, and we succeeded in shifting the company's focus to mobile. There were issues. As our mobile apps started to become more sophisticated, and the state-of-the-art kind of, expanded forward, and we were keeping up. We started to employ larger images, videos, rich animations, gestures, and the web browser, it just couldn't really keep up. It couldn't keep up with all this stuff. We had, at best, poor frame rate. And more often than not, what would happen is we would consume all the available memory on the device and would crash the app. And while Apple originally announced iOS as a platform for the web, with the web browser as the primary tool for app developers, it's pretty clear now that mobile app is not their priority. So every new version of iOS that's come out, they've made awesome new improvements, new APIs for native development, but have not fixed bugs or improved performance of web to nearly the same degree. And on Android, this problem is even worse. So in the beginning of 2012, we started an effort to develop a truly native version of Newsfeed on our iOS app. It's the first thing you see when you open the app, and it's the most important thing where people spend their time. This sounds obvious. It's the right thing to do. But it was far from a modest undertaking. For the first time ever, our client side was doing a lot of the application work that our servers used to do. And it doesn't speak in terms of page URLs and HTML, but instead in terms of models and views. This required us to rethink our whole architectural stack. In order to serve native apps the data that they needed to fill their models and render their views, we had to figure out how to request and prepare and deliver that data from our existing servers, which up until that point had designed to deliver only HTML. So we tried a couple things. We started with our RESTful public API. As we went down this path, we realized that we were writing tons of client code to deal with the network. We had to coordinate multiple requests to get all the information that we needed, which is multiple round trips that can be really slow. Also, each request had a slightly different response shape, and it wasn't always the shape that we actually wanted for the model for our app. So there's also a lot of custom parsing logic. So at the time, the RESTful API was designed for a different audience with different goals in mind. It queries individual resources, and it's good at that. But we needed something more structured. So FQL, this is Facebook's publicly exposed API using a variant of the SQL language for querying all of our public information. And it's a really powerful tool. It's really awesome. It exposes data in a structured way, and for a while this actually met our needs. But as our app started to get more complicated, as we started to support more use cases in Newsfeed, very few of us could understand these complicated multi-join queries across multiple tables. And it was really easy to make mistakes. It was really easy to overfetch information, and maintenance of these things was really hard. And we realized that beyond any surface level issue, what we really didn't like about these approaches is that they didn't present data in the way that we think about data. We don't think about data in terms of join tables, secondary keys, or resource URLs. We think about our data in terms of objects, properties, and relationships. We think about our data as a graph. Most importantly, we think about our data in terms of the models that we ultimately use in our apps, whether that's JSON or NS objects. So with this in mind, a few of us started building what would become GraphQL as a way of expressing the needs of our client apps in terms of how our product designers and developers actually think about the underlying data. And this seemed to work. A couple months later, GraphQL was powering a newly built version of native Newsfeed, and the first iOS app powered by GraphQL hit the App Store a little over 3 years ago now. And GraphQL today delivers data to thousands of active versions of our native mobile applications and serves over 260 billion requests per day. So this is a real thing that we're using in production. This new architectural stack powered by GraphQL has become the primary way that we build mobile applications and the servers that power them at Facebook. And we've continued to evolve GraphQL over the years. And most recently, we launched Relay, which brings a lot of what we've learned about using GraphQL in our native mobile apps and brings it back to the web. It brings the whole thing full circle, which is pretty cool. So let's take a look at GraphQL and see how it feels to use this. This is the hello world of GraphQL queries. I want to query my name. The first thing you'll probably notice is this looks pretty similar to JSON. You have these curly braces that look like objects. We call those selection sets. And within those are some things that look a little bit like object keys. So we call those fields. And fields can themselves have selection sets, which allows us to describe nested requests. And if we send this query as a string to a GraphQL server, it gets parsed and executed, and the response looks like this. So you can see that the response and the query have the same structure. And this is a really important part of why GraphQL is really easy to learn and use. A GraphQL query describes the shape of its resulting data. And so here, the name field is a property of my user object on Facebook. But what exactly is me field a property of? Well, at the top level of every GraphQL query is the entire graph, all of the information. And since the graph has no starting point, no middle, no end, the fields offered at the top provide various points of access to start a request. So in this example, me is how I get my Facebook user, but this isn't the only way to do that. Actually, here's another way, a more programmatic way, to access my user object, or for anyone else for that matter. This pattern of looking things up by ID, it's really common in GraphQL for the same reason it's really common in a lot of query systems. And ID here is a field argument. So providing field arguments allows us to change the behavior of a field. You can think of fields like functions that return values, and sometimes functions need arguments. We can also request fields that have complex values. So here, profile picture is a complex field. It has some information about width and height, as well as a URL to load the image. And I bet you can already guess what this is going to look like when we run this query, since we described the shape. We always specify our queries down to scalar leaf fields. And this ensures that there's no ambiguity in what we're asking for. There's no over or under fetching, and the result is always predictable based on the query. And at Facebook, profile pictures actually come in a lot of sizes. So while the default one here is 50 by 50, we can actually request one of a specific size. Again, we're using a field argument to change the behavior. We are able to fetch a different size profile picture by supplying this argument. And what if we want multiple profile pictures, different sizes? Well, we can request the same field multiple times by using aliases. Alias allows for a field that the server knows about to be returned in the resulting JSON with a different key, which allows us to request the same thing multiple times. So here we have little pic and big pic in the same query that are both mirrored in the resulting response. But most importantly, GraphQL is designed not just to query the properties of an object, but to smoothly follow connections between those objects. For example, I can query not just my name, but also the names of all of my friends. And notice that here is where SQL would require a join table, or where REST API would expose more URLs that you would have to follow. And if I have 500 friends, that might be 500 URLs to follow. And GraphQL lets you express this naturally in a single round trip. Of course, you can do this as deeply as necessary for whatever app you're building. If I wanted not just my friends and their names, but the events and the names of those that they're attending, I can continue to naturally query at deeper levels. And I may want to trade off between having all of this information and the amount of time that it takes to load that information. So I can express constraints and limitations to the server by using field arguments. And this is the basis for paginating through larger lists. So that's how we speak GraphQL. There are a handful of core principles that make GraphQL a truly powerful utility. The language is powerful because it models data in the same way that product designers and developers think about and use the resulting data that comes back. So it's easy to imagine what the resulting data is going to look like just by seeing a query, and it's pretty easy to write a query if you know what data you need. But GraphQL is a lot more than just its language. At the core of GraphQL is a type system, which you define, that expresses all of the capabilities of your server. At each level in a GraphQL query, a particular type applies, describing what fields are available, what arguments can be supplied to each field, and what type will result from requesting that field. So here are all the types from the previous examples we've shown so far. Let's look at them in terms of a query. So here's one of the queries we already looked at. We're going to get my name, a profile pic, one of my friends, and the next event that they're attending. We can start at the top type, the query type, which describes the two things we've seen so far, me and user. We're going to request the me field. Within that, we return a user. So now we can ask for the fields described by the user type. And the type system doesn't just describe fields, but the arguments as well. So in this case, order by is an argument that accepts one of three possible values described by friend order enum here. And this is an example of GraphQL describing not just what's possible, but what's not possible. So if a list ordering is too expensive, you don't want someone to order by something that isn't indexed, you just don't expose it. And the orderings don't have to be fields. So importance here is an ordering heuristic that doesn't actually appear as a field in the type. So this is more extensible than a lot of other query languages. Profile picture, we can get the width, height, and URL. And friends here returns a list of users. So we represent that down here in square braces. And then we're going to request the events field, which is itself a list, but of events. And within events, we can ask for the name. And because we know what type is being queried at every level of a query, we can ensure that only correct queries can be requested. So in typical applications, an app server owns the model data while the client owns the views. A client might ask for a model, usually by giving some ID, and the server can respond with the data for that model. But this produces a coupling, where any change made to a client requires a similar change on the app server. Keeping these two in sync while maintaining historical versions can lead to serious debt. As these iterate, we need to continue to update the version of the server as well. And this can be made even more challenging if you have to support more than one client application. When you're using GraphQL, a server expresses the complete set of possibilities that it is capable of fulfilling by the type system, which allows clients to precisely describe their data needs in terms of single queries based on those types, so a data shape in a single request. This is a separation of concerns. It allows for a single server to support a wide array of clients with very different needs, because the server actually knows less about those clients. And more importantly, it allows for the continual evolution of those over time. So when a client developer changes how their app works, they often don't need to touch a server at all. At Facebook, this has allowed us to support dozens of different applications across many different platforms. It also allows us to support all of the past versions of these apps with minimal technical debt on our servers. Many of our applications release new versions to their App Store or Play Store every week, and often with slightly different data needs than the week before. And we still support that first version of native newsfeed iOS app that we launched over 3 years ago. People are still using it. It's kind of hard to believe. And now we've released more than 1,000 different versions of our various client apps over 3 years, and they're all using the same version of the GraphQL server. So our next powerful principle is composition. GraphQL is designed with composition in mind. Every level of a query appears in a similar style, which makes assembling queries natural and mirrors the composed objects and the responses. And in order to match how client developers think about UIs, we had to have an ability for pieces of the query to be repeated or moved to different locations. So we added a feature called fragments. Fragments allow us to take the same portion of a query, use it multiple places. More importantly, it allows us to put it in a UI component to describe only the data that one component needs. For example, here we have a profile picture. Profile picture needs width, height, and URL. And we have a profile pic React element here that is going to access that information. We can then take that component and compose it into another one. So here we have this person row. And person row has its own information that it needs. It needs name and whether or not we're friends in order to render this add friend button. And it's going to defer to the add friend or the profile pic component to render the rest. And it's going to use fragments to refer to the other data that it needs so that we're not repeating this information in places, and that information can stay co-located to the place where it's needed. This is the same compositional technique that makes building UIs with React really pleasant. The same pattern we can apply to data requirements. So when we build larger, more complicated applications, we can couple data requirements to the UIs that use them, which makes it way easier to avoid overfetching or underfetching, allows us to add and remove fields with confidence to ensure that we're not going to break something. And in fact, this is the approach that Relay takes for describing the data needs of a whole application made up of many small components. Another one of GraphQL's powerful principles is that it's backed by your code. It is not a predefined storage engine. When we first put GraphQL on Newsfeed, we were already using this sophisticated ranking and storage model, and changing that was just a total non-starter. And in addition to that, we had a different database where all of our user information was stored, and this additional layer of caching information for images and links. And we just couldn't make any assumptions about storage, and we just had to focus on a way to tie unrelated stores of information together. But not only that, we had all this existing business logic. We couldn't repeat that stuff. So in order for GraphQL to be widely useful, it had to have the ability to reuse all this existing application code that we had. So we designed GraphQL to take advantage of existing code. One of its most powerful properties is that it is not a storage engine. It makes no assumptions about how you access data, and it leverages your existing application code. It means you get to keep your code, and this is a critical part of why we're able to roll GraphQL out so quickly in 2012. We had to change very little of how Newsfeed actually worked under the hood. So here's how that works. Each GraphQL type is tied to a little bit of code. A type is just a list of fields. So let's check out user type. We have name, profile pic, and friends. And for each of these, we have a function. So each field is just a function. It takes the value of the previous field as its input and produces a new value as its output. Because it's a function, you can do anything that your server is capable of doing. So you can do simple stuff like read properties of the previous value. You can, of course, call other functions. You can load stuff from other various databases. You can produce derived data, stuff that's too complicated for clients to do themselves. And field functions can be asynchronous. In JavaScript here, we can return promises or arrays of promises. And this is actually really common in GraphQL, where we're fetching information from many different backends that are all asynchronous. GraphQL is going to fulfill our query using as much parallelism as possible, which is less error-prone and usually actually more efficient than manually chaining together promises to do this ourselves. At the very least, it's just more pleasant to write code this way. And GraphQL is not a read-only system. It also allows writes. But GraphQL writes don't work like RESTful APIs or existing client mutable models. GraphQL is inspired by the Flux programming model, and we submit mutations in the form of actions as fields in a GraphQL type. So mutation fields, they're still backed by any arbitrary function on the server with no assumptions, which means that you can integrate with all kinds of different services for doing mutation, logging, whatever else you need to do in a mutation. In the type system, it's so critical to how GraphQL works on the server in order to execute safe queries only that we wanted clients of GraphQL to have access to the same information. we just needed a way to get this information down to the client. Like, if only we had some way to query structured information from a server, this could be really easy. So we exposed this through GraphQL itself. So we have a special top-level field that we call dunder schema, which allows us to request a description of the entire type system. It tells us everything a GraphQL server can do. We call this introspection, and it provides us with an extremely powerful tool for building other tools. Here's just a couple examples of things we can do with that. We could do API documentation. So how many of you here have ever experienced API docs that are either out of date with their implementation, have just big gaps of missing docs, or are just like buggy, like they're out of sync, right? Like if I don't see all hands, then I know I have. It's super frustrating. It makes it hard to do our jobs. And it's also really hard to maintain that stuff. It's hard to keep it so that, our hands can stay down. One of the pieces of information that introspection exposes is a field called description, which is just a little bit of markdown formatted text on every type, on every field of every type, on every argument of every field. And because descriptions are actually part of the type system, they're defined when you define types, it makes it really easy to make sure that they're always up to date. We can also generate code that you'd otherwise have to write manually. So given a query, since we know the exact shape that the server is going to come back with, then we can just automatically generate model objects, fast custom parsers, or if you use Flow, we can generate flow types. And knowledge of this type system, it lets IDEs go beyond just syntax highlighting. We can present context-sensitive type aheads, and we can do real-time error detection. And this has huge implications on productivity and the sanity of client app developers like us. We can also statically verify that a query is correct before we submit it. And this is really cool. We call this query validation, and it allows us to find and avoid bugs that we'd otherwise only find when we actually ran these queries. And by integrating this in with other tools, we can do things like have commit hooks so that bad queries can just simply never be checked into any of our repositories. And a lot of these features show up in a tool that we use at Facebook called GraphQL. I'm going to show you a little demo of this. Hopefully you can see the screen okay. So this is GraphQL, and what this lets you do is, on the left side of the screen, type a query, and we support some of those things that I was talking about. So if there's a syntax error, you can highlight over that and see that. As you start typing, we'll show a type ahead of what you're allowed to type at that particular point. We do other interesting things like if you haven't queried down to a leaf and you hit enter, we'll automatically fill in fields for you. And on the other side of the screen here, you see a response. And now that we're down in this query and we start type aheading, we're only getting the relevant fields for that particular point on the query. So here we're querying a couple fields, and we can kind of scroll down through this thing manually. We could also just type, and this type ahead will work pretty much how you would expect it to work. Again, enter, autofill the stuff as it makes sense to do so. Query a couple more fields. And now as we run this, the information is updated on the other side. We can kind of scroll through this stuff, check this out. And this is a rich JSON viewer as well. So it's not just like, curl where you get this stuff dumped out in your terminal. Instead, we can go through and kind of poke around. We have code folding on both sides, the editor and in the response. So this is really a full-featured IDE that we can use. And at Facebook, this is a really important part of how we develop things at Facebook by using GraphQL. So that's GraphQL. What started as a tool for us to build just a great version of native newsfeed has grown to be a critical part of how we build almost all of our applications, and now with Relay, how we build for the web as well. GraphQL lets us decouple how we build our servers from how we build our client apps, and it lets our servers focus on expressing what's possible in the form of a type system. And it lets our apps focus on supplying their requirements in a language that favors composition and fits the mental model of product designers and developers. And via introspection, we can build powerful tools for using GraphQL by using GraphQL. So when we built GraphQL for Newsfeed 3 years ago, we just had no idea how critical it was going to become to Facebook. And we also just had no idea that we would ever use it outside of Facebook. We built it really fast, and it was really tightly tied to how our internal infrastructure worked. And over the last few years, we've continued to evolve GraphQL to cover more use cases at Facebook, but the same quirks, inconsistencies, idiosyncratic nature, assumptions, all the stuff that we started with, it was all still in there, and it made sharing GraphQL outside of Facebook a real challenge. But since January, inspired by the enthusiasm of this community, actually, Nick, Dan, and I, and a couple others on our team, we got to work reevaluating all of the details of GraphQL, making improvements, fixing the inconsistencies, and we wrote a specification that describes GraphQL and how it works. So earlier this summer, we released an RFC for the GraphQL spec. We've already collected some feedback on this, and we've actually improved the spec. We've made some changes, and we hope to continue to receive feedback. So we're only a little over a month into this, and it's just getting exciting. And we've also shared some real code that you can actually use. We built a second implementation of GraphQL. We use PHP for our server backends at Facebook, but we built another version of this in JavaScript that complies with our specification that is also public as of a little more than a month ago. We chose JavaScript not just because we like it, but because the same source can be used by so many people, especially in this community. We can use it for building GraphQL servers using Node, and we can use it for building client-side tools. So the graphical that I showed you was built using GraphQL for JavaScript as well. The library has continued to improve since we launched it earlier this summer. It's also beginning to do its job as a reference implementation. So now if you go look, you can find some work-in-progress GraphQL implementations for Ruby, Python, and Go, which is really exciting. And we're just really getting started. Since the original launch of GraphQL.js and the spec, we've launched a handful of other tools. Of course, Relay as well, launched just a week or so ago. But there's another tool people have been asking me if we will release, Graphical. You know, at Facebook, this is such a critical part of how we use GraphQL at scale. All of our engineers use this tool. And we want to build a community that's using the same tools that we're using internally. So actually, right before I got up on stage here, I released Graphical on NPM and GitHub. So I hope that this ends up being a useful tool. Go check it out. And for those of you just starting to explore GraphQL, I hope that this helps sort of feel through the pieces of GraphQL and learn it by doing rather than having to read a specification. And it's built to be extended, so I'm super excited to see how people use it and extend it. So we see GraphQL as a common way to describe and request information regardless of the language or environment of either your backend server or your client application. We're excited to build a community around this, around GraphQL and the tools around it. And we're super excited about what we can build together. So with that, thanks so much for having me. My name is Lee. Come find me afterwards if you have questions. Thanks a lot.